Okay, let's get started on our first lesson in geometry. I want to show you something. This lesson that we're going to be doing is fairly long, and many of the words that we're going to talk about today are right here in your book. So, I mean, a lot of the slides I have today are right off the book. So, just keep that in mind as you're working through the assignment. If you don't remember the PowerPoint per se, you could just look up the things in the book. Also, we're going to be doing a study guide, and this will be your classwork. So usually when I do a study guide, you have some words to fill in. A lot of these are vocabulary words that you can just get out of the book also, and it's just meant to reinforce some of the vocabulary that we cover and so on and so forth. So this first study guide is very short, and anyhow, let's go ahead and get started. Like I said, there's lots of terminology, and that's just this first lesson today that will have this many new words and stuff. Primarily, we're going to learn how to name things in geometry, and well, let's go ahead and get started. So lesson 1.1 has to do with identifying points, lines, and planes. But we'll also talk about segments and some other things as well. So our essential question and our objective, students will be able to name and sketch geometric figures. That's what this stands for. Students will be able to. And you'll see this almost on every objective I do. So anyhow, the essential question is, how do you name geometric figures? So here's a picture where several geometric ideas are like identified here. Like here, this idea here, it looks like a football play, but we have some points. The points represent players. You have these yard line things. Those are kind of like segments. And the football field itself is kind of flat, and it kind of reminds us of a plane in geometry. And so anyhow, we have points, lines, planes in geometry. These words, we say they're undefined. I mean, it's like they don't have a formal definition, but there's an agreement about what they mean. So this may seem confusing at first, but here's an undefined term, and here's how what we're going to do is tell you some things about it. It's not a Webster dictionary definition. It's just, these are some of the characteristics. For example, a point has no dimension. It is represented by a dot. And so when you draw a point, we often use a capital letter, and we're going to go into this in just a little bit, but we say that this is a point. But it's just a representation, because a point has no dimension. And so, well, what does that mean? It means it has no size. The point is, let's say you had this big point here, and you said, well, that's a point. Well, what would happen if you erased half of it? What would that be? What's that remains? Is that a half point? Or is that a quarter point? Is that a third point? Well, as you might imagine, you can keep erasing and erasing and erasing more and more and more, and eventually you have a quarter point, an eighth point, a 16th point, a 32nd point. And the point is that, well, just how small is a point? And there is no set size for a point, and so that's what we mean by no dimension. But we just represent it by a dot, just like you normally would. Anyhow, kind of a confusing idea. If it has no size, how do you even draw one? That's kind of interesting. You can trip out on that a little bit. So we use capital letters. We always use capital letters with points. No lowercase letters. So now let's talk about lines. Lines, we have to use 2 points. And there's a couple ways we can name a line, and I'd like to go over 3 ways that we can name this line right here. One way is just to use the two letters, and we could use two letters that lie on the line. So we could call this line AB, and we have to include the line symbol on top. The line symbol on top has two arrowheads. Okay, so like that. We can also call this, we can use any two letters we want that are on the line. So if there were a third letter, we could use the third letter, but we could call this line BA also. BA, and as long as we put the line symbol. Now, to make matters worse though, we have a third way, and you'll notice that points on a line always have capital letters. Well, what's this letter over here? This is letter L, but it's a script letter, and you'll notice also that it's a lowercase script letter. So there's another convention to make things confusing. We will also use script letters to name lines, but when we use that convention, we'll call it like, we'll use the word line with it, line, and then we'll use the script letter, line L. That's supposed to be an L. Okay, in any event, when we use the script letter, it's always lowercase, and we usually put the script letter above the arrowhead or right near the arrowhead. The arrowheads are used to indicate that a line goes on forever in that direction. So it actually continues that way, and the line continues that way. You know, imagine my lines are straight. Lines are straight. So in any event, I'm not that good with my sketch pad, but anyhow, you can see there's three ways that we've named this particular line, and if there were a third point on there, like point C, we could even call it line CA, as long as we put the line symbol on top. Now this symbol on top is going to be important because segments are something that we're going to talk about also. They use a symbol on top, but it's a different symbol. So as we go through this chapter, you're going to want to keep track of all the different symbols. Okay, so let's get back to the lesson. Okay, so we talk about planes. Now, planes are similar to lines in a sense as far as naming goes. However, a key difference is that we always use three letters. And the letters can be used, we can use the letters in any order. Like, for example, we could name this, I'm going to try a different color now. Liven things up a little bit. Let's try blue. So we could name this, for example, plane. We could call it plane. And the key here is just to use three letters that lie in the plane. So we could call it plane A, B, C. And of course, you can have any order of the three letters. And so you could call this plane B, C, A. And so you might imagine there's a whole bunch of ways that you can name a plane. You could call it ACB and CBA, and you know, there's probably 6 different ways you could just use the letter combinations. Well, what's this letter over here? Once again, this is another convention that makes things a little bit more confusing. That's a script letter, and you'll notice there's no point being drawn underneath that M there. And you'll notice also that this script letter is in like a corner. Sometimes we put the script letter in the corner of the plane. And so when we're using this one, we'll use, notice it's a capital letter this time. So we'll call this plane, and we'll just use the single letter. But when we use this convention, it has to be like the script letter, kind of like handwriting. There's plain M, and it's supposed to be like handwriting, and it's supposed to be the capital letter. So lines use lowercase, planes use uppercase italics letters and script letters. So you got to keep everything straight in geometry, and that's primarily what this first section is about. It's about how do we name things. One thing you should notice about a plane is that a plane doesn't really have these boundaries here. We just draw it with boundaries just to help us identify a plane in a diagram. But notice 2 things. It has 2 dimensions. It has this direction, this direction, that's one dimension, and two dimensions. And so a plane will always have two dimensions. But here's the other thing, it extends without end. So the plane actually goes on forever in that direction and goes on forever in this direction, goes on forever in that direction. It doesn't have a third dimension. The third dimension would be going upwards, I think, and downwards. So this dimension does not exist for a plane, and on this particular example anyways. A plane could go upwards if it's at some angle. Let me try and draw one real quick that's going vertical. Here's a plane that's going vertical. I'll try and draw it anyway. That plane is like going, that one's going up and down. You see, so you can draw two-dimensional plane that's going vertical. That's okay. In this case, the third dimension would be going left and right. I'll try and draw that real quick. So it would be this way. The third dimension would be going that way. You know, a plane is always a two-dimensional idea. It's kind of flat like a sheet of paper. So try not to get too confused. Okay, so we learned about naming them. You can use these any three letters, or you can use this little italics method where you use one letter, and that you'll be able to identify because it will be in the corner, in one of the corners of the plane. Alright, so there's a little postulate that we should know. A postulate is like a rule about, it's a rule about our mathematics. It's a rule about geometric figures that it's like a law of mathematics. Sometimes we call these laws postulates, sometimes we call them theorems, sometimes we call them axioms. But for now, I'll just say that this is a postulate. It says through any 3 points not on the same line, there is exactly one plane. Now this is a little hard to understand. Why do we say that they can't be on the same line? You see this little phrase right here. And what I'd like to do is try to convince you that they cannot be on the same line. So let me go to a new piece of paper and I'll draw a plane. Alright, so here's a plane I've drawn, and there's like this plane. I'll make it kind of big here and try and draw it straight. Alright, so there's a plane, and now let's just draw a line that's on that plane. Okay, so I'm going to try and draw it right here. There's a line, and I want you to imagine for a moment that it's a straight line. Okay, and I want you to imagine that there's 3 points on this line right here. We'll just call this A, B, and C. So you see those 3 points. Now we'd like to name this plane, and we'd like to say, well, the plane, we'd like to call this green thing, we're going to call it plane. What do we call it? We'll just call it A, B, C. Now that's okay. That seems like okay, but let's notice here that this may cause some confusion. There might be another plane that kind of goes at this angle here, and I'm going to try and draw this, and you'll notice that this plane also has this line going through it as well. See this line, this black line, or now it's blue, it goes through the blue plane as well. So when you use letters A, B, and C, how do you know if you're talking about the green plane or if you're talking about the blue plane? You see, when the 3 points lie on the same line, it leads to this confusion where we don't know which plane you're talking about. So that's why we have this rule that they can be non-collinear. That means they cannot all 3 lie on the same line. So let's say, for example, we replace that, and I use my green pen. Now let's say the 3rd point is over here. Now you'll notice that these 3 points, A, B, and C, they lie in the green plane, but they don't lie in the blue plane. So you can use 3 points to name the green plane, and as long as they're not all 3 on the same line, there will be no confusion. So now we can call this A, B, and call this point C, for example. And now that we'd be very sure that we're talking about the green plane. On the other hand, if we had this point over here, and we call this one like point D, and now we're using A, B, and D, well, now we know that we're talking about the blue plane instead of the green plane. So that idea that we're using there on the previous, it says any 3 points not on the same line. That part is important, not on the same line, and it helps us eliminate confusion when there's more than one plane in the diagram. And if we do that, we say there's exactly one plane. Here's another idea. 3 points that are not on the same line. You can use any 3 points that are not on the same line to name a plane. So here's another issue that we'd have. If we were to put a point right there and call that point D, for example, we could not use those 3 points if there were a line drawn through those 3 points, because just like I said before, if the 3 points lie on the same line, there might be another plane that would pass through those same 3 points as well. So that's what this message here is. 3 points that are not on the same line you can use 3 points that are not on the same line to name a plane. So we could use this point, and we can use this point because they're not on the same line. But we can't use those 3 because they are on the same line. So anyhow, it's a little bit confusing, but I can assure you as we go through this chapter, things will be a little bit more clear. So now we get to this idea of collinear. Collinear points. They are points that lie on the same line. Now I've always found this real easy to remember because in the word itself you have this word right here. Linear. Collinear points. So they're points that lie on the same line. And we have another word that's very similar. It's called coplanar. And to me, I never got these confused because there's the word line and there's basically the word plane. If that letter were an E, you'd have plane right there. So these are points that lie in the same plane. These are points that lie in the same line. Let me just draw a picture of each one of these. There's a line. Okay. There's 3 points there. And what we could say, for example, use brown here. Chocolate, my favorite color, favorite candy. We would say points A, B, and C are collinear. And we have a point over here where you have point D. A, B, and C are not collinear with D. They're collinear with A, B, and C. A, B, and C are because they're on the same line, but D is non-collinear. So that's the basic idea of collinear. Now, coplanar, let's just draw a plane now. Here's a plane going along right here. It's an ugly looking plane. Now we can put some points in the plane. And you can have as many as you like. And this would be like point A, B, C, D, maybe E. So we could say the points A, B, C, and D, and E are all collinear, not collinear. We need to use this word, coplanar. All those points are coplanar. But if you had a point up here, like point F, this point is like hovering above the plane. And it's like up above it. It's not in the plane. Planes are two-dimensional. So this plane goes forever this way, and goes forever this way, and goes forever this way. But this plane is kind of going underneath this point. Let's imagine this point is up above. And of course you could have points below as well. But point F is not coplanar with those other points because they're not in the same plane. Pretty easy idea, right? Okay, let's continue. Now let's just go ahead and practice a little bit. Let's see here. You want to give two other names for line PQ. And if you need to, you can go back in this video and find out how to do it, or you can use your book. But anyhow, let's review a little bit. We learned that we had to have a line symbol on top if we're using the two letters. Well, where is PQ anyways? You know what? I noticed this happens every single time I do this lesson. There's part of this slide that's missing. There's supposed to be like a letter right here. I'll call this point Q. Okay, so that being said, we can finish this question or try to answer it here. Another name to name this line PQ, this one going kind of upwards at an angle, we could call it QP. As long as we use the line symbol on top. Okay? But notice there's a script letter. Now remember, with lines we always use the lowercase script letter, and it's always near an arrowhead. So another way to name that line is just simply call this line, and we use the lowercase letter N, and just try to write it like you would in handwriting way back in first grade or second grade. So that's how we can name the line. Now how about the plane, this kind of red plane kind of going sideways here? As long as we use three letters that aren't all on the same line. You cannot use S, P, and T because those three letters are all on the same line going sideways here. But you could use S, P, and V, or you could use V, P, and T. R, what's this R? That's not a point because notice there's no dot by it. Remember, we use dots to represent points. This is that script letter. So, and that's what they're using right here, script letter. Let's use three letters though. We're going to call this plain. Well, we're going to call it V, S, and T. That would work. Another name that you can do, you can use, like I said, any combination of these three letters. You can call it plain S, P, V. Now again, you could have used any order here as well, and that would work. So you'll notice there's many ways to name a plane. But what you could not do, you cannot do this one. This one would actually, plane, you cannot use S, P, T. I'm going to use red now and put an X through this one. We can't use this one. This one is wrong because those three lie on the same line, and we were told we can't do that. And you could easily have another plane that goes through at another angle like this, that goes through those same exact points, and now we'd be confused. Well, are you talking about that plane, this one going horizontal, or are you talking about this plane that's going diagonal? You see, so if the 3 points lie on the same line, it can be confusing about which plane you're talking about. You'll notice it sort of makes an angle as it goes through the other plane. So this one does not work. Alright, well, let's continue. We did some practice. Name 3 points that are collinear. Well, alright, these are new words for us, and I have them memorized already, but I've been teaching this for a while. Collinear. Remember, there's a little hint right here in the word itself, line. Oh, I need 3 points that are on the same line. Well, in this case, it'd be S, comma, P, comma, T. Use commas to separate your points. All right, how about 4 points that are coplanar? Well, again, there's that kind of word right there in the word itself, plane. If this were an E, it would be plane. So we're looking for 4 points that lie in the same plane. Well, this is, again, don't use this point. That's not a point. And so the answer for this one, we can say, oh, V is inside the plane, comma. S, P, and T are also. S, P, and T. Those are points that are coplanar. Okay? So you sort of get the idea what collinear and coplanar work, what they mean. Now here's a chance for you to work out a problem. We just worked out a problem together. For this example, I'd like you to do yourself, and it's very similar to the previous example. And then you can also practice naming a plane. Here is a new diagram. I'll let you do that yourself. We can pause the video at this point and come back to it in just a moment. So why don't you go ahead and do that, and we'll start here in just a few seconds. Okay, so in addition to those two that we just did, you could also do these two. I'll give you another 30 seconds or so. Name 3 points that are collinear. Name 4 points that are coplanar. Okay, so let's go ahead and continue. So now we're talking about parts of lines. Remember, lines go on forever, but segments and rays, they consist of part of lines. And so here's a good exercise. Read the definition of a segment and see if you can draw one. Okay, so it says, what it says is it consists of endpoints, A and B, and all the points that are between A and B. So a segment is part of a line. Notice it's all the points on line right here. Segment is a part of a line because you start off with this line. Remember, you have to have 2 points to name a line. So here's a point, here's a point, here's A and B. There's your starting point. You have a line AB. Now the segment, though, does not include everything, though. It has the endpoints A and B. So this part here is missing, and this part here is missing. You see, this is what we call a segment. It has the endpoints A and B. It has these 2 endpoints. This point here is what we call an end point. Okay, because in this case it's basically the end of the segment. It goes no further. This point also is also an end point. So the segment includes all these other points between A and B. So it's these points, all these points right here that are between A and B. So naturally it includes every one of these, and if you put enough points on there, you get the whole segment. Well, anyhow, hopefully you came up with that diagram when you tried it yourself, and that's what we call a segment. Now, naturally, we'd like to know, well, how do you name segments? So let's find out how to name them. So I'm going to back up just a little bit because I didn't want to talk about rays yet. So let's talk about naming them real quick. Segments are similar to not lines when you name them, except for, you notice there's no script letter this time. Script letters are only used for lines, not for segments. So it turns out there's only two ways to name this segment. We can call it segment AB, and we use 2 letters, capital letters, because those are points. We use capital letters with points, but they use a segment symbol instead. Now, segment symbol has no arrowheads on top. If you had the arrowheads on top, it would make this a line. So another way to name this segment would be BA. You can switch the letters around, but once again you have to use the segment symbol on top, and there's no arrowheads. So we have lines, segments, and now let's talk about rays. Oh, phew. Lots of terminology. Okay, so here's a ray. Now a ray, this one is very confusing when it comes to naming. You'll notice that a ray actually is a part of a line. In fact, sometimes you could think of it as a half line. Like, let me start off with the line again. Try to build this up here a little bit. You start off with a line like we did before, and you have 2 points, A and B. And when you have your line originally, it goes on forever this way, and it goes on forever this way. Now, if you were to erase part of it and come up to this point right here, that would make this point on the left an end point. So there's your end point. Okay? And the other side goes on forever. This is what we call a ray. And it's kind of like a bow and arrow. Like you have an arrow that's kind of pointing. As you might imagine, the ray can go in the opposite direction as well. We could have had a ray going this way. And how do we discern? I mean, how do we tell which one's which? Is this ray AB or is it BA or whatever? I mean, it's a little bit confusing. So here's the thing that we always do when we're doing rays. We have to name the endpoint first. Like for example, if we're naming this ray, we'd start off with the endpoint. So we would call this one ray A. We use the 2 letters again, ray AB. We use a generic ray symbol on top. A ray symbol only has 1 arrowhead on top. And so that's our symbol for a ray. Now, if we wanted to name the ray going the opposite direction, this ray going this way, well, in this case, B would be the end point, and A would be the part that's on the ray. So we're naming this ray here. We'd have to start off with the letter B. I'm going to call it letter B, and we'll use the letter A. Now, the symbol that goes on top is a generic symbol. It always points to the right. And don't worry, the ray symbol has nothing to do with the direction of the ray itself. It's just a generic symbol. So we put the generic symbol on top. This ray, the black one, is BA. Okay? The blue one is AB. So we have to be careful when naming rays. We can't just switch the letters around like we do when we name lines and like we do when we name segments. The first letter has to be the end point. The end point goes first. Okay? So there's the end point for the blue ray, and that's why we start off with A here. Here's the end point for the second ray, which is right there, you see. And so that's why on this one it went first, BA. Well, hopefully this is making sense. I know it can be overwhelming because we've had a lot of terminology in one lesson. And so we have one more word. They're called opposite rays. And take a close look at this picture. And let me draw the 2 rays separately. You have this ray that kind of goes this way. Okay. And that's the ray that we call CA. So this ray, we'd name it, and we'd call it CA. So there's that ray. Okay. Well, now we have a ray that goes this way, goes in the opposite direction. That one's going left, and this one is going right. Now notice that they both have the same endpoint. Okay, so when you have the same endpoint twice and they're going in opposite directions, then we say we have opposite rays. And so notice this would be the endpoint for this red ray, so this we call this one CB. And again, we put the ray symbol on top, and they go in opposite directions, and so this is what's meant by opposite rays. Pretty easy idea, right? Phew. Alright, so let's practice a little bit. Give another name for segment. Now notice this is talking about segment here because of the symbol on top. So in this portion they're talking about GH. GH is this segment from here to here. Remember, a segment, it's like a part of a line. So the only way we can name that segment another way is just to switch the letters around. We can call this segment HG also, but it needs to have the symbol on top, like that. Well, now what do we want to do? We want to name all the rays with endpoint J. Okay, what it means is that it has to start at J. So you can actually have a ray going this way, and how would we name that one? Well, J is the first letter, that's the endpoint, so as long as we call this J, E, we have to put the ray symbol on top, that's that one. Now let me switch and show you another one. Here's another ray that goes this way, and that ray we would call JH. And once again, we've got to put the ray symbol on top. But you could also have a third ray that's going this way. Okay. And that one we'd call JG. And then we could even have a fourth ray, and I'll bet you could even guess already where it's at. It's this one going this way, and we can call that one JF. Okay, and there's 4 rays that start off with the endpoint J. Now they're asking, well, which ones are opposite rays? Well, the opposite rays right here would be these two. Those two are opposite rays. Opposite. We'll just abbreviate here. Those are opposite because they go in opposite directions. One's going to the left, one's going to the right. And then there's another set of opposite rays, which would be these two. The black one and the green one are going opposite rays, and they have that common point right here. So we reviewed now naming rays and opposite rays and segments, and pretty easy stuff as long as you can remember everything. Now here's a chance for you to get some practice. So why don't you we'll pause the video for a moment so you can practice this on your own. I'll give you a couple minutes, and then I could review the answers and make sure you got them right. Okay, so we should be back now. How could we name EF? Well, EF, first of all, EF is this ray up here. Okay, so there it is, and they called it EF. Well, the only thing we can do is switch the letters around, so we could call it FE. Now we have to make sure we put the symbol, correct symbol on top. There's the symbol for segment. So there's segment FE. Now let's try this one. Oh, kind of interesting. This one and this one. I'm going to use my red pen so you can see the difference. HJ, are they the same ray? Well, HJ would be this ray. Okay. because it has an endpoint right there. It's H, and it's going to the right, and includes every point that's on that. Because this goes on forever, it's a line to the right side anyways. So is that ray the same as this one, JH? Well, JH actually would be this ray. It starts here and it's going this way. It's kind of going in the opposite direction. So we'd say no, those are not the same ray. Okay. Let's use my eraser now and let's try the second part here. The next part here, are HJ and HG the same ray? Well, HJ we've already seen is this one. Okay. It has an endpoint of H, right? And HG now, I'll use a different color here. Use my red one. HG would start right here also and keep going this way also. And it passes through this point G also. So you can see, well, these two are actually the same ray. And so we'd say yes, yes. And what's this part? How do we explain that? Well, they're the same ray because they have the same endpoint and then they're going the same direction. So they have the same endpoint. And I'm going to abbreviate endpoint. I'm going to start using PT for point. Same endpoint, and they're going in the same direction. Same direction. And that would be a good enough explanation for the explanation part. In other words, it's not enough just to have the same endpoint, because if they have the same endpoint, you could actually have a ray that goes this way. And so we need this part also, same direction. They're both going to the right. Okay, so anyhow, isn't geometry fun? Now I know you might be sick of geometry already. There's lots of terminology. But remember this, a life without geometry is pointless. Okay, I'll say that one more time. A life without geometry is pointless. Alright, that's a little joke for the day. Okay, so now let's talk about a word called intersection. The main thing for intersection, and we'll use this word several times in mathematics, it's something that's being shared. I mean, think about it. You've known this all your life already. When you have two roads that come together, here's a road that goes this way, here's another road here, and here's a road here. You know, imagine there's cars traveling down. Well, what do we call the intersection? We call the intersection this portion right here, right? This portion right here. The reason why we call it the intersection is because both roads share this part. This road shares this part, this road shares this part. The red part is the shared part, and it's what we call the intersection. Well, the same is true in geometry. It says two or more figures intersect if they have one or more common points. The intersection of a figure is a set of figures that have in common. Some examples are shown below. Let's take a look at them. There's an intersection that includes just a single point. When two lines intersect, there's a common intersection of one point. You'll notice though, when two planes intersect, the entire line here is the intersection. Remember, it's a line, not a segment, because planes go on forever. This plane, this blue plane, is actually going on forever this way and this way. So this line will be continuing to be joined together. It's part of the intersection with the red plane and the blue plane. Again, it's the points that are common. These points right here are common to the red plane, but they're also common to the blue plane. So that's what we call an intersection. Let me show you another little picture. Here's a Venn diagram that shows you the idea of intersection. What's common to both of these groups here? There's group A, here's group B. The intersection would be this part. It's common to both. Okay. And this is another picture of the intersection. So hopefully those three examples will help you understand what intersection is. Now we're going to practice drawing a little bit. A lot of people have trouble drawing geometric figures at first, and we're going to have to be okay at drawing things. We don't have to be experts, but let's try to draw these three figures, or excuse me, these three examples. We want to draw a plane, and we want to draw a line that's in that plane. Okay, so here's this one. Now we draw a generic plane, just kind of like so. And now we need to draw a line that's in it. Well, here's a line that's in it. Okay. There's points A and B. Now I know this bothers you a little bit. Take a look here. Doesn't this line go outside the plane after a while? It went outside. Well, that's the thing you need to remember. Planes don't end. This plane actually goes on forever that way. It goes on forever this way. And it goes on forever this way. So it turns out this entire line will always be inside the plane. If it starts inside the plane, like right here, then it always will be in the plane. Lines are straight, and so planes are straight and they're flat, and so that line will always be in the plane. Well, let's move on to the second one. Okay, sketch a plane and a line that does not intersect the plane. Okay, so we'll start off with the plane. There's our generic plane. Okay, here's part B. Okay, part B is part A. Okay, sketch a plane and a line that does not intersect. Okay, so the line cannot touch. It cannot touch the plane anywhere. So maybe you could think of a line that's floating above. So let's put a line like right here. Let's say there's a line. Oh, this is going to be hard for me to do. Hard for me to draw that straight. There's a line that's kind of going above. There's my point here. Make that point big. And make this one big. And see, so you can kind of think of this. There's this red plane that's kind of going underneath the line. And it's like flying underneath. And then there's this line that's flying above it. And at no point do they have any common points together. You see, so there's a sketch of a plane and a line that does not intersect. Okay, well, how about this third one? Sketch a plane and a line that intersect at a single point. Okay, I can do that. Here's a plane. Well, I'll just draw this plane going this way. Okay, now we have to draw a line that intersects it only at a single point. So here's how you do that. Just kind of go at some sort of angle and it hits right there. Bam! I'm going to put a single point there, and then we'll just say, hey, this kind of goes on underneath. It kind of goes like that. Okay, so there's my blue line, and I'm going to name that point, and I'll call this point Z. Okay, so that plane, this black plane, intersects the blue line at this point right here. And there's a single point. So sketch a plane and a line that intersect the plane at a point. Wow, that's ugly. Okay. Well, anyhow, you get the idea. So there's part C. When we've done parts A, B, and C. Oh, there's supposed to be an arrowhead on this line here. Okay. Alrighty, well, I think we're almost done. And Oh, now let's do one more thing. Sketch two planes that intersect in a line. Alright, I'm going to cover this one real quick. This one's very tricky to draw, okay? So let's start off with a generic plane going horizontal. So here's a plane that's kind of going left and right. Alright, so now I'm going to draw another plane. We want the intersection to be a line. So let's draw our line like this. There's our line. It's a blue line. It's kind of going through like this. It's a lot easier to draw with a ruler. Okay, so there's a line. There's this blue line going through that red plane. Okay, so we want an intersection to include that line also. And remember, lines have 2 points at least. Let me draw a black plane now. Now I'm going to draw a black plane kind of at an angle. I'm going to make like a 45-degree angle here. Going like this. 45-degree angle here. You know, about a 45-degree angle. And there's another plane that's kind of going this way now. And like hidden. There's this plane kind of going underneath. But there's a plane going this way also. And this plane shares that blue line also. The blue line is also in the black plane, and it's also in the red plane. So it's not the prettiest picture, but there's an example of this one. Well, that was a lot. And we're finally to the end here. And let's just summarize some of the things that we learned. This was by no means everything. But how do we name geometric figures? Well, we use a single letter to name a point. We use 2 letters to name a segment. We use 2 letters to name the endpoint and another point that's on a ray. 2 letters to name any point on a line, blah, 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 blah. We have collinear and coplanar. There's a lot of stuff. Now remember, as you're working on the assignment, you have your textbook, and if you get confused anywhere, if you look in your textbook, you can go to the next page. I have to renew this thing. You can go look in your textbook, find the answers. It's not too terribly hard. This first lesson just has to do with terminology. So there's some of the problems we did. You might recognize this. And so don't be afraid to use your textbook though. Here's some of the examples we did, drawing things. Okay, so by the way, you might find that doing some of these problems here, if you have colored pens or colored pencils, that might be make it a lot more helpful to draw some of these pictures. And draw one plane with one color, like notice they did blue and then they did green. Makes it a lot easier to visualize what's going on. Anyhow, I wanted to show you something. Some people say, well, where are we using mathematics? And is this, why do we need to learn this in the first place? So I want to show you an interesting video. This is right on YouTube. And we're not going to watch the whole video because it's 12 minutes. But we'll watch maybe a couple minutes just to give you an idea. But this is partly where geometry is being used in real life right now.
My colleagues and I are fascinated by the science of moving dots. So what are these dots? Well, it's all of us. And we're moving in our homes and our offices as we shop and we travel throughout our cities and around the world. And wouldn't it be great if we could understand all this movement, if we could find patterns and meaning and insight in it? And luckily for us, we live in a time where we're incredibly good at capturing information about ourselves. So whether it's through sensors or videos or apps, we can track our movement with incredibly fine detail. So, and it turns out, one of the places where we have the best data about movement is sports. So whether it's basketball or baseball or football or the other football. We're instrumenting our stadiums and our players to track their movements every fraction of a second. So what we're doing is turning our athletes into, you probably guessed it, moving dots. So we've got mountains of moving dots, and like most raw data, it's hard to deal with and not that interesting. But there are things that, for example, basketball coaches want to know. And the problem is they can't know them because they would have to watch every second of every game, remember it, and process it. And a person can't do that. But a machine can. The problem is a machine can't see the game with the eye of a coach. At least they couldn't until now. So what have we taught a machine to see? So we started simply. We taught it things like passes and shots and rebounds, things that most casual fans would know. And then we moved on to things slightly more complicated, events like post-ups and pick and rolls and isolations. And if you don't know them, that's okay. Most casual players probably do. Now, we've gotten to a point where today, the machine understands complex events like down screens.
Okay, so as you can see, we're using points, segments. Segments were like basically a pass, and we're able to model things, and we're using it as a coaching tool, and it's quite impressive. I mean, it's nice to be able to see that here's geometry being used in some software that coaches are now using, and I would urge you to finish watching this video. It's very interesting, especially if you're a sports nut and you enjoy playing sports like basketball. Finish watching this. It's a TED Talk, and you can just go to YouTube, type in the math behind basketball's wildest moves, and I would recommend watching the rest of the video, but I'm not going to watch it all right now. But it's a very good application of where geometry is being used, and if you're very good with cell phones, you might understand that one of the things we want to be able to do is track where someone's at when they're using their cell phone in case they get lost. And we want to be able to say, oh, we want to be able to tell police, or we want to be able to tell some authority where an emergency is, and sometimes you can track that emergency by just having your cell phone. So lots of interesting applications. Please don't think that mathematics is just something that we bore you with, but there's always all sorts of applications that you just don't know about, and this is a good example one. Thank you. I hope you enjoyed this lesson, and again, I'm sorry for all the definitions that we had, but that's just at the beginning here. Starting in the next lesson, there's a lot less definitions. All right, we'll see you tomorrow.